Jackson cross cylinder. The major technique in use today to determining the axis and power of cylindrical component of the refractive error is the Jackson cross cylinder technique, also called as flip cross cylinder technique. This video is about the optics and how to use the Jackson cross cylinder. First of all, let me introduce you with the JCC, that what is this and how is it made. Jackson cross cylinder is a combination of two cylinders of equal strength with opposite sign placed with the axis of 90° to each other, mounted in a handle for flipping. Here you can see this is how JCC looks like, having plus and minus cylinder with same power attached to handle, which helps in flipping the lenses quickly. Optics of cross cylinder, or how is it made? So a typical cross cylinder is made of a spherocylindrical lens which has zero spherical equivalent. A spherical power of the JCC is combined with a cylindrical power which will be twice the power of sphere with opposite sign. What does it mean? Let's understand with example. Plus 0.50 diopter spherical combined with -1 diopter cylinder. This results in a net power of plus 0.50 in one axis and minus 0.50 in other axis, and on doing the spherical equivalent of this you will get 0. Now if I talk about available powers of JCC, then JCC available in plus minus 0.25 diopter cylinder, plus minus 0.50 diopter cylinder, plus minus 0.75 diopter cylinder, and plus minus 1 diopter cylinder powers, out of which plus minus 0.25 and plus minus 0.50 are commonly used. When which power of JCC should be used? So here is the indications. 0.25 diopter cylinder JCC is indicated or used for patient who have a visual acuity of 6/9 or better. Plus minus 0.50 diopter cylinder JCC is indicated for patient who have a visual acuity of 6/12 or worse. Plus minus 0.75 JCC is indicated for patient having a visual acuity of 6/24 or worse. Plus minus 1 diopter cylinder is indicated when patient have a visual acuity of 6/60 or worse. And the visual acuity that I am mentioning here is the visual acuity with best vision sphere, because the JCC is used after best vision sphere is determined. Marking of principal meridians. The principal meridians are marked in the periphery of JCC lens with two different colors, where one indicates axis for minus cylinder and the other indicates axis for plus cylinder. Commonly used colors are red and green, where red indicates minus cylinder axis and green indicates plus cylinder axis. But it's always better to check axis before using JCC, that which color is denoting which cylinder. Principle of cross cylinder. JCC uses principle based on Stump's conoid by placing the circle of least confusion on the retina. Now before proceeding to the procedure, have a look on the uses of JCC. As we already know, JCC is used for refinement or verification of cylindrical power and axis of cylinder. Other than this, JCC can be used to assess the presence of astigmatism. So first we'll start with the verification of cylindrical axis or procedure for axis verification. After retinoscopy, we need to check the power and astigmatism found. This should be done in a systematic way. So axis of cylindrical correction should be verified with JCC before verifying cylindrical power, because correct axis can be found in the presence of incorrect power, but power cannot be found with incorrect axis. So start axis verification. First, patient should have one eye occluded. Then patient is asked to read the line above the best vision. Place the JCC with the handle in line with the axis line of the cylinder lens and call this as position 1. Now flip the JCC and call this as position 2, and ask the patient to compare the clarity of images in two positions. And before asking about image clarity, explain that both the view may make target less clear than before, and question should be like, is the letter more clear with lens in position 1 or lens in position 2? If the patient report no improvement of vision in two position of JCC, then axis of correcting cylinder in the trial frame is accurate. And if the patient report better image clarity with any of the two position, then cylindrical lens in the trial frame is rotated in the direction of the similar cylindrical component of JCC. In case of minus cylinder in the trial frame, follow the red line and rotate towards the red line which indicates axis of minus cylinder in JCC. In case of plus cylinder in the trial frame, follow the green line and rotate towards the green line which indicates axis of plus cylinder in JCC. Let's understand this with example. Here we have cylindrical lens with power minus 0.75 diopter cylinder. So from this, one thing keep in mind that you are going to follow the red line which indicates axis of minus cylinder in JCC. So putting JCC with handle aligning parallel to the axis of cylindrical lens in trial frame and call this as position 1. Then flip the lens and call this as position 2. And on asking, patient says this position is better. Then rotate the cylindrical lens towards the red line in 10-degree amount. And now again align JCC handle parallel to the new cylindrical axis and call this as new position 1. Flip the JCC and ask the patient about image clarity in both the positions. On asking, patient says image clarity is better with JCC lens in position 2. So rotate the cylindrical lens towards red line, but this time with lesser amount, that is 5 degree. And again align JCC with new cylinder axis. Then flip and ask the patient about image clarity, and patient says in both the position image clarity is same, and this is the end point of axis verification, and we have minus 0.75 at 175-degree axis. Now we'll see verification of cylindrical power. Verification of cylindrical power. The principle JCC uses for verifying cylindrical power is JCC will either increase or decrease the cylindrical power in the trial frame. For that, align the JCC axis with the cylindrical power axis in the trial frame. Flip the JCC and ask the patient to compare clarity of images in two position. If patient report no improvement of clarity in two position, the power of cylindrical lens in trial frame is correct. And if patient report better image clarity with any of the two position, then the cylindrical lens in the trial frame is replaced with new cylinder power. With red axis, add minus power with cylinder correction, and with green axis, add plus power with cylindrical correction. Now let's understand this with example. Here we have cylindrical lens with power minus 0.75 diopter cylinder at 175 degree. On that I am putting JCC with JCC axis over axis of cylindrical lens in the trial frame. Flipping the JCC and asking patient about image clarity in two position, and patient says position 2 is better. So the thing to note here is patient responds better with red axis. So new cylinder value will be cylindrical value in the trial frame minus 0.75 diopter cylinder plus minus 0.50 diopter cylinder, which is cylinder value of JCC, and new cylinder value is minus 1.25 diopter cylinder. Now again align the JCC, flip and ask the patient about image clarity in two positions. And this time patient says both the positions are not clear, and this becomes an point for power verification, and we have minus 1.25 diopter cylinder is the final value at 175-degree axis. This is determination of presence of astigmatism. This is to done when there is no cylinder value found in retinoscopy or AR value. So if no cylinder correction is present, place the cross cylinder in 90-degree and call this as position 1 and 180-degree meridian, and call this as position 2, and ask the patient to compare the clarity difference between images of two positions. 45 and 35 oblique meridians can also try. Using the JCC blurs the vision, so patient must be asked to read one line larger than vision achieved with best vision sphere. For example, if patient could read 6:9 with best sphere, then ask to read 6:12 with JCC, because keeping JCC before the eye blurs the vision. If patient reports image is equally blurred in two positions of JCC, then this indicates no astigmatism present. What if patient report better image clarity with any of the two positions? Indicates that the eye has astigmatism, and add cylindrical lenses parallel to the plus and minus axis of JCC until the two images become equally blurred. That we have done already in determination verification of axis and verification of power. So this was about the Jackson cross cylinder. Hope this will help you. Thank you for watching.